This is the homework help for Math 3 Unit 5, Worksheet 11. So I'm going to start with question number 5. So the directions for number 5 say to graph the relation and its inverse. So we want to graph this and then its inverse. So if I look at this equation right here, I have that y equals the square root of x plus 4. And it's in the correct form to find my vertex or start point. So my vertex or start point is going to be a negative 4. So I look to see what's affecting the x. So that's plus 4. So I'm going to do the opposite, negative 4. And I'm not adding or subtracting anything to my y value. So that would be y equals 0. And then my stretch is the number multiplying my function. So I'm not multiplying anything there. So I can always have an implied 1. So my start point is negative 4, 0. And then my stretch is 1, so up 1 over 1. So if I want to graph, so there's my relation, and now I want to graph my relation's inverse. So I want to go and reflect this and do the mirror image across the diagonal y equals x. So I'm going to turn this real quick. So that means that this graph right here needs to reflect across the diagonal and be a mirror image of itself. So I know that my start point for my relation is negative 4, 0. So its inverse will be the reflection of that. So I switch the x and the y value, so at 0, negative 4, right? 0, negative 4. So this point right here, that was at negative 4, 0. I just flip it around and graph 0, negative 4 instead. So over 0, down 4. And then let me do a different color there. So over 0, down 4. Okay. And then the other point that I have, so I have my second point right here, which I got from my stretch. So that point right now is at 1, 2, 3, at negative 3. 1, right? So this second point that I got was at negative 3, 1 from my stretch. So then the inverse point, so I want to switch that around, would be at 1, negative 3. So at 1, negative 3. And so when I want to do its inverse, it's going to be a reflection, so it's going to look something like that. So I took my stretch, flipped it around, so 0, negative 4, and then the second point I got from my stretch at negative 3, 1, I graphed it at 1, negative 3, right? So if I look at this graph and this graph, although not perfect, they are mirror images of each other. And so there is the relation and its inverse. Okay, so for question number 6, we want to find the inverse of each function. So to do that, I know that I want to switch the x's and the y's. So f of x is the same as y. So to find the inverse, I'm going to flip-flop the x and the y. So instead of y equals, it's going to be x equals, and then 4 minus 2y. And then once I do that, so this is for part A, then I want to solve for y. So once I switch the x and y, solve for y. So I'm going to subtract 4 over to the other side. And then I'm going to divide everything by negative 2. And when I do that, I want to make sure I write it where I'm dividing everything by negative 2 instead of like all over negative 2. So this will reduce here. So I have an implied 1 in front, right? So this would be 1 over negative 2 is the same as negative 1/2, right? So negative 1/2 x. And then a double negative is a positive, and 4 divided by 2 is 2. And then I want to indicate that this is the inverse function. So instead of y now, I'm going to write it as f inverse of x equals negative 1/2 x plus 2. So there is my inverse function, so that's part A. And then now for part B, C, and D, the easiest way to find domain and range on everything is to graph it, and then to state whether or not it's the inverse. We also want to graph so we can check to see if it passes the horizontal line test. So for part B, I want to find the domain and range of the function. So I'm going to graph this. So let me do that over here. So I'm going to just take this equation and do that over here. So this would be y equals 4 minus 2x. So to graph that, I want to put that in standard form. So I know the 4 is not affecting the x, because if it were, it would be grouped in parentheses. So the 4 should be over on the other side, so I'm going to subtract 4 over. And then I want to find either my start point or my stretch. So my start would be at 0, because I'm not adding in or subtracting anything to x. And then instead of negative 4, positive 4. So alphabetical order, x before y. So my h and my k. And then my stretch is negative 2. So I'm going to go over 0, up 4. And then my stretch is negative 2, so down 2 over 1. And then this is linear because I'm not squaring anything, rooting anything, so then it's just going to be up to the left 1, and then I'm going to draw my straight line. So then for my domain, for part B, is going to be negative infinity to positive infinity, because the arrows here mean I'm going forever left and forever up, and then this arrow here means I'm going forever right and forever down, right? So I have arrows going up and left and down and right, so that means the 4 corners are going to be infinities. And so then for my range, it will also be negative infinity to positive infinity, so bottom comma top. So my domain and range of my function is going to be positive and negative infinity. Now for my inverse, so because my domain and range for my function is positive and negative infinity, so will be my inverse. So I could graph this as well, but I know this is going to be a line, right? So I could graph it to do that, but I know it's a line, so it's going to also be the same domain and range, because we're going to infinity in all directions, regardless of graphing that line or graphing that line. And then for part D, state whether or not the inverse is a function. So if I look here, does it pass the horizontal line test? And it does, because there's no horizontal line that I can draw that will intersect my function more than once. So then yes, my inverse is a function. Okay. All right. And then let's take a look at number 12. So for part A, I want to find f inverse of x. So I know f of x is the same as y, so I'm going to replace my x with my y and my y with my x. So this will be x equals the square root of 1 minus y. And then I want to solve for y, so I'm going to square both sides. And the square root and the square cancel, right? And then I want to subtract 1 over. And then divide everything by negative 1. So then this would be negative, like a 1 here. So 1 divided by negative 1 is negative 1. And negative 1 divided by negative 1 is positive 1. And then rewrite this so it's in inverse notation. So y is going to switch back into f inverse, because that's what I just found was my inverse function. And then negative 1x squared is the same as negative x squared plus 1. And then for part B, I want to find f inverse of 0. So I'm going to take this equation I have here and replace the x with 0. So instead of x here, I'm going to use a 0. And then instead of this x here, I'm going to use a 0 as well. So negative 0 squared is just 0. And then when I add 1, 0 plus 1 is 1. And then for part C, I want to find f inverse of f of negative 8. So I'm going to replace, so I want to find this first, right? So f of negative 8, start from the inside, work your way out. So I'm going back to my original function here. And I'm going to replace x with negative 8. So instead of x here, I'll have 1 minus x, which is negative 8. And then the double negative is a positive, so that would be 1 plus 8. And the square root of 9 is 3. So that just gave me this part, right? So now I know f inverse of negative 8 is 3, right? So now I want to find f inverse of 3. So I'm going to do it just like I did part B. I'm going to use this equation right here, right? So instead of x, I'm going to use 3. So instead of negative x squared, it'll be negative 3 squared, and then plus 1. So I'm squaring only the 3. So 3 squared is 9, and negative 9 plus 1 is negative 8. And I should get negative 8, right? Because if you remember, f inverse and f cancel each other, so my result is just 8. Okay. And then for part D, so the same thing. So I want to find f inverse of f of x. So I know f of x from the original problem is the square root of 1 minus x. Right? So let me look over here. So I know f of x is the square root of 1 minus x, and that's from the original. So all I did was replace f of x with my expression. And so now I have f inverse of the square root of 1 minus x. So let me zoom out just a little bit. So I'm going to replace that x with the square root of 1 minus x. So instead of negative x squared, it's going to be that is squared. And then plus 1. So I have exactly the same thing here, right? So negative something squared plus 1. So negative something squared plus 1, but my something is root 1 minus x. And then I know that the root and the squared cancel. So I have negative 1 minus x plus 1. So the root and the squared cancel. So I have negative 1 minus x. I'm going to distribute the negative. So that's negative 1 plus x, and then plus 1. The negatives cancel, and I get x. And we should just get an x, right? Because the inverse function and f canceled, leaving us with just x. But we still have to do our proof, right, to verify that. And then that's it.